Okay, so welcome to the first topic in the Physics 9120 course, Mechanics for Teachers. In this set of videos, we'll be reviewing scalars and vectors, I'd say with about a 99% focus on the vectors. So the videos will cover the formal definitions of scalars and vectors, vector notation and vector algebra in 1, 2 and 3 dimensions. I assume some prior knowledge, so I assume that you know what the Cartesian coordinate system is, as well as how to draw vectors in it, as well as some basic geometry and trigonometry, so the Pythagoras theorem and the sine, cos and tan trig identities. I will cover those briefly as we use them, but for those of you that require a more in-depth review, I will also provide some links to some very good online resources under the relevant videos. So you already use and deal with the description of three-dimensional space on a daily basis because we live in it. So for example, whenever you're looking for something or asking for direction somewhere, you're dealing with the description of the location or the description of the movement of objects in space. So all we're going to do in the following set of videos is to formalize that. So to cover the formal terms and equations that physicists and engineers will use. So there are two definitions or two terms that describe how we describe space. And the first of those is a scalar, and a scalar is something which describes magnitude only. So for example, if we imagine for a minute that we live in a two-dimensional world, we have a pilot coming into land and he describes his position as 100 kilometers from the airport. This is a scalar description, but in this case it's not actually very useful because there's a very large range of locations that could be 100 kilometers from the airport, and it makes life slightly tricky for the control tower. So what he will use instead is a vector. And a vector is something which will describe both the magnitude and direction of his location. So for example, the aeroplane being 100 kilometers northeast from the airport. And such a description allows the control tower to very precisely pinpoint his location, which is altogether much more useful. So it's for this reason that we will most commonly be dealing with vectors in this topic. But before we move on to the more formal vector notation and algebra, I think there's probably one important question that needs to be answered, which is why. So why is it important that we go through the motions of learning this? A lot of vectors is going to be memorization, rote learning, memorization and practice, and practice and practice and practice. And it's quite hard to stay motivated if you don't really know why you need to do that. So in physics and in most engineering disciplines, you will at some point in your career be dealing with vectors. They're the basic tools of the trade. So for example, if you will ever deal with the description of objects in space or the prediction of their movement, so a somewhat topical example, weather prediction, so the prediction of the strength and the path of cyclones and bushfires. These people are saving countless lives at the minute, and the basis of what they're doing is vectors. Likewise in physics, so everything from the very small in quantum mechanics all the way up to the very, very large in astrophysics. So as an example, the guys that are predicting whether or not meteors will hit Earth or just miss us, it's all done with vectors and some forces. Or in a more engineering bent, the people that are designing objects to move through space or to move space about. So things like Formula 1 cars and aeroplanes, as well as things like mining equipment and windmills. These are all done using CAD programs, and the basis of those programs is vectors. Or finally, if you are ever intending to be one of those lucky few that is piloting objects through space, so an astronaut or an aeroplane pilot or a ship's captain, all of these people deal with their control towers using vectors, and also deal with other pilots in the nearby vicinity using vectors. So hopefully I've given you enough examples to keep you going. In the next video we'll start looking at the vector notation.